between spongy and bold sound?
Usually that's the rectifier.
No, because there's a separate that has, they ask you if you want tube or solid state rectification. They say it explicitly. And then there's another switch, it's spongy or bold.
I'd like to, okay. If you got any documentation, I'd like to see it.
Yeah, so
Boogie's pretty good too about putting stuff online. They have like technical stuff on simulcast and various things that they have. But yeah, you bring that in. Cool. Yeah, I mean this stuff is, there's always something new to discover with these things. People have done all kinds of stuff. But this is one thing that doesn't really change, the basic gain stage. And, and this is what I was talking about, that if you squint, you look at it, this could be, this could be anything here, right? It could be a VGAT, it could be a MOSFET. They all have vaguely similar gain stages. Sure, you got to worry about whether you're capacitively coupling or input or output or whatever, but they all look kind of similar. And the idea is, you can even draw this through analogy. Here, the input is applied to the grid. Well, that's like a gate or a MOSFET. The output signal is off the plate. Well, that's like the drain. And the cathode is floated above ground. You can tie it directly to ground. That's a special case for you. But that's like the source. So the idea is you want this point here to be about half of the total voltage range, right? Because this is where your output's coming from. So the way you get maximum swing on your output is to put this at about half the plate voltage. So this is the plate voltage. You've got some resistance here, some quiescent current through the tube, and some resistance here. Okay? So you ideally bias it so that based on the quiescent current, this is half the plate voltage. Then you have filters as well. This capacitor helps stabilize the cathode. It keeps the swing on this side from varying too widely, but it acts like a filter, short side frequencies to ground, so that this resistance is effectively reactive. So the gain is reactive. So that's important to note that every gain stage in the tube amp has a bit of filtering going on. The other filter is on the output. Now, since this is remember this voltage has to be negative relative to the cathode, and the cathode is floating a little bit above ground. So maybe say this is ground, this is a few volts. Usually this doesn't go above like 25 volts. Actually, it stays a lot less. It's around like 7 to 10 because this capacitor is valued at usually 25 volts. Like when you swap out caps on the amp, you'll see the cathode capacity is usually 25 volt caps. Whereas the caps tied to the plate voltage are usually 600 volt caps. Because even if it doesn't get to 600 volt, that's a high level that you can see. So this voltage, again, this is a coupling capacitor. Since this is at half the plate voltage, and this is going to be tied to another grid, right, another gain stage, you need to remove the DC voltage. So you use a coupling capacitor. Now there are some directly coupled tube circuits as well, but by and large you'll see a coupling capacitor. Again, this and this form a filter network. So every tube gain stage has two filtering effects. So they all kind of serve to boost the mid-range a bit. They have a little bit of low pass, a little bit of a high pass. All right, so here's an example. Fender twin reverb. I wish I could bring this one in. I don't have one. It's a big one. It's a good complicated circuit. You look at this and it's like, what is everything? Well, after today, hopefully you'll be able to break it down. We'll look at the parts. First thing you should be able to figure out, where's the power supply? Exactly. Look for the transformer, you got your power supply. Where's the power amp? Yeah, where's the power amp? Well, I guess I haven't really talked about the different gain stages. We'll get that. You've got a preamp gain stage, right? That takes small signals and makes them bigger. And then the last thing is a power amplifier, which is what we were talking about. We were talking about amplifier classes. We're talking about power amps. So the power amp is what drives all the voltage and the current to move the speaker. So where's the power amp in this case?
The 6L6 there.
Right. It's next to the speaker.
Yeah.
All right. So preamps, tones. Let's get into the details of what's going on here now. So let's look at isolating. What I've done now is I've kind of broken this up into different sections. So Okay, so here it is broken up into sections. So, like I said, the power amp tied to the speaker. And almost always, there is one semi-famous design that doesn't use this, although I don't know of anybody that's actually commercial building. But otherwise, everything, tube amps always use output transformers. Okay? And this is one of the big reasons why everybody wanted to switch to transistors, because transistors didn't need output transformers. And the reason why is tubes have high internal resistances. So if you want to drive a load, it's got to be a high impedance load. Well, speakers are low impedance loads. 4 ohms, 8 ohms, 16 ohms. Those are all pretty low when you need something that's in the kilo ohm range for your load. So you use a transformer to do it. So tube amps almost always have two transformers. Your power transformer and your output transformer. Usually you see them, they're two big things. We'll get to some cases where you don't have a power transformer, but by and large you almost always have an output, except for that one design that I've read about but never seen in existence. Okay, so that's the power amp. Let's look at the far other end of the audio section, the preamp. The job of the preamp is to amplify that guitar signal before you do anything else to it, so that it's a substantial signal level, right? So you've got gain stages. The first thing it does is signal comes in, goes to a gain stage. That's a buffer, right? The idea there is that this buffers the input signal so that anything else after doesn't load the signal down. So you've got a buffer stage. What's right after that buffer stage is this passive network of resistors and capacitors. What is that? Tone. We'll look at tone. The tone stack is interesting. This is one of these things that's evolved from, I'm not sure where it came from RCA, but definitely from Fender to Marshall. And, it's still in existence. That even when you've got something like a Mesa Boogie with the 5-band graphic equalizer, you also still have that passive tone stack. So this is they call it the tone stack because they're stacked on top of each other. After all this is another section that we haven't talked about previously. That's the phase inverter. And the principle there is basically, if you've got a Class AB amplifier, right? You drive one side does the positive side, one side does the negative side. But you don't really have a negative power supply. You have just a positive power supply. So what you need to do is you need to invert that negative side to get the lower half of it amplified effectively. That's what the inverter does. The phase inverter takes a single-ended input and it creates two out-of-phase signals. And the two out-of-phase signals go to the two halves of the push-pull Class AB amplifier. So that's what makes it, push-pull. And you can do push-pull Class A. Okay. Power supply, we'll get a look at the details in there. It looks a little blurry on this plot. When we look at the next plot, I'll blow it up a bit, it's easier. You can still see, here's the high voltage section, here's the heater section, just like I drew. And then you can see obviously we've got solid state rectification because there are a bunch of diodes strung together. And then you get some caps and this network here, we'll take a look at that. All right, so what I left out was the pink section. Those are effects. Now, we talked about this last week. I brought in the Vibro Champ, which of course had tremolo in it. Well, the Fender Twin Reverb had its own tremolo, and it obviously had reverb. So these two sections have the circuitry necessary to do the tremolo and reverb. So this section here is the tremolo. And you'll see that this is an oscillator that generates a low frequency. And then this device here is an opto isolator. I think I mentioned it last week, the Vibro Champ uses a bias trem. This particular model of Twin Reverb uses an opto trem. So it creates a frequency, an oscillator frequency that's below the audible range, drives a light bulb with that, and that light bulb varies the resistance, and that resistance is tied into the gain structure, so that it reduces the amplitude rhythmically. Now the reverb, the way that works is, you've got basically a buffer driver stage, that couples to a transformer, and the transformer drives the reverb unit. And with the reverb unit, if you've never seen a reverb unit, actually there's one inside this Mesa Boogie.